Hey, everybody, I got to update that. I got to update it to say summer 2022 or maybe fall 20. Oh my gosh, it's going to be fall 2022. This one I made that. I made that in spring 2020. Good to see you, Gustavo. Good to see you, Jessica. Good to see you, Sierra. Good to see you, Shreya. Good to see you, KP, Lindsay, Tim, Kirsten, Noah. How's everyone doing this morning? Say hey in the chat if you haven't already, but we have a lot of people saying, hey, Matt, great to see you here. What questions are there? Let's start off with some points. Does anyone know what day today is other than it being Wednesday? Can anyone tell people? Good to see your Rod. Who's any of my students? Productivity. Let's be productive in a moment. In a moment, we'll be productive. Does anyone know what day it is? We have a theme for today. Does anyone know what day it is? We'll see if you'll say. I'll give you a hint. It's Wacky Wednesdays. Little Crash Bandicoot right there for you. But if you have questions, put them in the chat. We'll get started here with some questions. Crashing into our chat right there. But what questions do you have? Just drop them in the chat, whether it be 201, 474, 475. Let me know. Not even close. It's about as far away as my birthday as it gets. Because, yeah, my birthday's in January. So, pretty far away. Pretty far away. I'm 40. I'm old. I'm in my 40s. See, it's fun saying you're in your 40s when you're in your young 40s. I guess it's fun when you're in your late 40s too, because then you're like, I'm in my 40s and it's ending. But the middle of the distribution, the middle 40s is where you're like, I'm in my 40s. What questions do you have? 201, 474, 475. Good to see you here, Knox. Any questions you have, whether it be 201, just introduction to statistics, 474, 475, you name it, we can get started on that work and start doing some analysis. For 7.2b for the lab, is printing summary of the product column considered existing? Oh, so you don't have to knit those, Tim. Good questions, Tim, right there. Let's bring up the lab right there and kind of walk through that 7.2b for the lab. And so we should, I think we get through everything today we need to. I'm really zoomed out in R. Let's go do a little 474 for 201. Good question on 201. Should I find the mean, median, etc. by hand through jump? I'd find it, we'll do that next year, Michelle. I would find it by hand. We'll talk about how to find those and how I would do them for the test. So let me write down these two notes right here. We have for the first questions, can you go over calculating standard deviation? Definitely. So we got great questions. Question 4 on chapter 2. That's 201, right, Gabriel? I think so. Let me write down all these questions. Thank you for all the questions. So we have BS 474. And we try to just keep giving questions. Question 7.2b lab. We'll put on one more song right here while I write these down. And then we will start doing these. There we go. And then we have Stat 201, Chapter 2, Finding Values with Jump or by hand. That'll kind of cover the standard deviation 2 from Isabel. Good question, Isabel. And then question 4, Gabriel. So the quizzes actually change it up. Stacking and splitting histograms. Good question right there. The quizzes split it up to 1. So if you're in 201, let me know which question you're working on, because the quizzes will change what's going on. Is Mubot? Oh, is he on the screen? Mubot. Brian.
You don't even know how to do my voice, Brian.
Mubot. It's gone rogue, man. Can't trust a Mubot. If you can say which specific questions, stacking and splitting histograms. I got that question, Matt. That's chapter 4, stacking and splitting. And then there's a question on lab 1, 4H and 4I. Ooh, lots of questions. Love it. So lab 1 question. Maybe I'll do the 201 and then I'll break into the 474. So if you're here for 201, I'm going to do 201 and then we're going to do the labs for 474 some. And that was 4H and 4I. Okay. I've got these written down. Was it Gabriel? Gabriel, if you can expand upon which question you're doing, the quizzes change the questions. The quizzes change the question. Great job. And thank you, Matt, working ahead. Good work right there. I guess it's coming up, right? Ooh, goes fast, goes fast. It's a question about the stem and leaf, asking for the meaning. Okay, awesome. So stem and leaf, let me put that right here. That's chapter 2, right? So Stat 201, chapter 2, MyPearson, stem and leaf. And it asks you for the IQR and all that good stuff. Awesome. What is the conventional number of bins to use for histograms in R? That's a really good question. BS474, how does R assign bins? We'll look into that, Tim. That's a really good question. It has like a default, I think, and it's called breaks. The argument is breaks. Okay, let's start out right here with a little bit of 201. We got tons of questions, and let's talk about finding values by hand and or finding them with jump. Here we go. Okay, so our first topic today is finding values like the mean, the median, the IQR, all those values by hand or using jump. So first thing I want to do is get you ready for either, what do you think, the homework or the test? What do you think is most important? Now, don't go in first. Yeah, go with subset. You bet, KP. Do you think we should understand the homework better or what's going to be on the test? What do you think? The homework or the test? And the answer is the test. The test is the big important thing. So we get all the attempts we want at the homework, but the test is closed notes. Make sure you know that. So we really want to understand how to find these values by hand. So let's talk about a few specific values. Oh, no, don't worry, Michelle. Points right there for saying homework. Homework is first. So, you know, some people could say we should do the homework first and then study for the test. That's an acceptable answer. So why not 50 points? Great work, Michelle, right there. Jump in. We love the answers. So the first value to find, and let's put a little note right here. Okay, we're going to open up a little Word document and type beside this. The mean. Let's talk about finding the mean. To find the mean, what do you do? Just if you know how to find the mean by hand, talk to me about it. Let's say the mean. How do you find the mean with all these values right here? Now, it's a little bit cumbersome by hand to do it. So the mean is a value you need to know how to find by hand because you won't have jump or Excel on the test. But if you want to find the mean, how are you going to find it for these data values right here? Add all the numbers and divide by the total. You're right. Add up all the numbers, divide by the total. So to do this right here, you'd have to go, and this is going to be fun, but we'll do it. 800 plus 1350 plus 1150 plus 1000. If you make a typo, you get it wrong. Plus 550. Oh, did I do it? Uh-oh. Oh, I'm scared. And then we divide by 10. That doesn't look right. That doesn't look right. Because we have a really big outlier up here. I don't even think I added in the outlier. So you kind of want to, and that's kind of good that I made an error right there. Kind of want to watch as you're doing this. And think about the mean should be heavily influenced by outliers. And that's a really good note to have if you don't have it. The mean is a value that is heavily influenced. There we go. The mean is heavily influenced by outliers. So that 8,000 is going to pull the mean towards the high side. So the mean is not a good measure of center for this data due to outliers. The mean is a better measure of center for unimodal symmetric data. More unimodal, more symmetric, better measure is the mean. What is the proper measure of center for this data right here? So who can tell me in the chat for 20 points right here? This data should have a measure of center explained by the what? This data over here, because it's got an extreme value, it's got a very large outlier. The better measure of center is the median. 20 points right there. Great job, Isabella. The median, turn it on a little bit. Now you have to find the middle value. Now, there is an equation for this. I'm not a huge fan of it. You can do n plus 1 divided by 2, and that will find you the position of the middle value. So n is the number of observations, and these are both, I wanted to show me my little, there we go. It was up there in the paragraph thing. Say measures of center. So here's your measures of center right here. The mean versus the median. These are two measures of center. Question for Shiny. Ooh, good question on the Shiny. Shreya, let's do that. We'll do that on the 475. So we'll do that after 474. Thank you, Shreya. I'm going to just copy it as is so I don't forget about this. Thank you, Shreya, right there. And we will get to that. Thank you so much. And so why do we have two measures of center? Mean is for data that's what? Repeated again, 201. This is on the test. We're doing some test practice here. Mean is for data that is what? You add up all the numbers, divide by the total. Mean is for data that is what? The mean is for data that is what? This is a note you should have up. You'll say, what do I need to write down? Mean is a measure of center. It's used for data that is what? Not skewed. That's a great answer right there, Michelle. Not skewed. Data that's more like normal, or it could be flat. It doesn't have extreme outliers like this one has an extreme value up here. So that's when we use the mean. Now, the median is not going to be impacted by skew because it's the middle number. Now, this is not the value of the median. What would be 10 right here? There's a lot of ways to do it. I like to make a seesaw when I do it. You'll see me do that here in a second. But what would be, did I say n if I said the number? What would be the value of n right here? Using this equation to find the middle number, what would be n? This is one way of doing it. So you can find the position of the median using this right here, this equation. N plus 1 divided by 2. Great job, Sierra. It's 10. So what does this solve to? And you'll see why it's the median. If you solve this equation right here, 10 plus 1 divided by 2, what do you get mathematically? And then I'll show you why it's the median, like why that gives the value of the median, or the position, excuse me. See, when I make some errors. It gives 5.5. Great job, Sierra, rocking out there. Great job. So if you notice, 5.5 would be right there. And what does 5.5 do? 5.5 divides it into 2 equal portions. There is no middle number. You'll notice if there's an odd amount of numbers like 11, there would be a middle number, but there is no middle number. So the median for this data set is the average of those 2 numbers. And what is the median of this data set now? Which is a better measure of where the center of it is at. What is the median of this data set? So there is no middle number. And if there is no middle number, because there's 5 upper numbers, 5 lower numbers, then the middle number would be the average of the 2 middle numbers that are connecting the data, the top and the bottom. And so the median for this data would be what? 775. Great job, Isabel, right there. So these values we need to find by hand on the test. So I would suggest just finding by hand. We don't do really big data sets on the test. 10 numbers is a good amount. 8. I think the most we've ever done is like 20. I'm not even a fan of doing 20 numbers. Then it would be the 10.5th number, because 21 divided by 2. Not a big fan of doing that large of stuff. So you'll probably have a smaller data set like this where you have to find the mean and the median. Now we have 2 measures. There's technically 3. So for 50 points each, what are some measures of spread? What are some measures of spread? Does anyone know right now in the chat measures of spread for data? What are some measures of spread? Then we're going to talk about how to find them, and then we're going to show how to find them in JUMP also. Great job. The IQR, standing for the interquartile range, and the range also, and then also the standard deviation. Now what I'm going to do, we got all 3 of them right there. So I'm going to highlight mean. Let's put it in a nice blue right here. And then we're going to go right here and we're going to say standard deviation. Find with software. So the standard deviation gives us an idea of how far things are typically spread out from the mean. When you talk about a standard deviation, it is a measure of variation or spread. It's probably best explained if I show you 2 different distributions. If we were to talk about home runs for baseball players, a typical baseball player, and we'll pretend these are normally distributed, a typical baseball player might get in a season, let's say, 15 home runs. Does that make sense? Like in a season, the average, because we're using a mean right here, the average home runs is 15. Does that make sense? This is the center. That's why we call it the center of a distribution. Now, what we would say is there's a standard deviation of 5. So now when you do a standard deviation of 5, it's the standardized unit of distance you go up and down. And that means most baseball players, if not all of them, generally get between how many and how many home runs. If a standard deviation is 5, where we say normally distributed with a mean of 15, that's the mean value, and a standard deviation of 5, most, if not all, baseball players would get between what and what home runs. Most, if not all, baseball players would get between, good to see you, William, here. Most, if not all, baseball players would probably get between what and what. There might be some outliers, 10 and 20 is going to be the middle 68%. So that's the middle 68%, which is a lot of players. That's the middle 68% of players. This is chapter 5 right now a little bit. So that's the middle 68% of players. You could say between 5 and 25 is the middle 95%. But most, if not all, baseball players would get between... Who sees it? We'll see if someone saw it right there. This is the 99.7%. Most, if not all, baseball players would get between 0 to 30. So when you're drawing the normal curve, we go up and down how many standard deviations on the normal curve. So these are now standard deviations. These are z-scores. This is a lot of chapter 5, but a little introduction to it because you're going to be doing it soon. We go up and down how many standard deviations on the normal curve. We go up and down how many standard deviations on the normal curve. We go up and down 3. So the normal curve generally, and there's beyond 3 standard deviations that would be, extreme outliers. Like someone getting like 45, 50 home runs is like, whoa, that's crazy. But the standard deviation gives us an idea of how far things are away from the mean, because imagine this. What if I talked about yards in football? Now, in a football season, an average football player might get 600 yards. And the standard deviation might be 200. So what would be an unusually, here we'll do 800 rather. What would be an unusually low amount of yards for a football player to get? So use the standard deviation here now to tell me what would be an unusually low amount of yards for a football player to get. What would be an unusually low amount of yards? Like you'd be like, wow, that was really bad season. Like, wow, that's among the worst. Man, even Brian Stevens could do that. I couldn't. This is where I'd be. What would be unusually low? Go down 3 standard deviations. A standard deviation being 200, go down 3 standard deviations. So we go to 800 and we go 600. Does everyone see each time I'm just going down a standard deviation? Great job right there, Matt and Michelle and Gabriel and Knox. Great work. Does everyone see you just go down a standard deviation each time? And that's the unit difference you go down right here is 200. So that's down a standard deviation. So you could say someone with 600 yards has a z-score, that's what a z-score is, of -1. So if my football player has a z-score of 2, how many yards did they get? If my football player had a z-score of 2 and think that means they're 2 standard deviations above the mean, they had how many yards? If my football player had a z-score of 2, use the information on the screen, they got how many yards? Great job, Isabel, right there. Yep. And standard deviations tell you the distances things are away. It's how much are things varying from the mean. So if you noticed with the baseball example, there was a smaller standard deviation because, a difference of 50 home runs is crazy. But imagine a difference of 50 yards between football players. A difference of 50 yards between football players is not as big because there's more variation in yards than there are in home runs. Does everyone hear that? If you have 50 more home runs than someone, that's insane. If you have 50 more yards, that's good, but it's just a quarter of a standard deviation. So that's why we use standard deviations to give data context to tell us what these differences mean. 50 home runs is a huge difference, where 50 yards is like, that's good, but I don't know. 50 yards, you're about in the same ballpark of each other. They don't play football in ballparks, So that is why we have standard deviations. Now, here's the really good news when it comes to standard deviations. We find it with software. To find the standard deviation with software, go here to Analyze. Make sure that you have quantitative data. Analyze, quantitative data, distribution. Quantitative means it's blue and jump. Right here, you see this blue? That means price of computer is quantitative. Go to distribution, double-click the variable, and make sure it appears. There it appears. And now you'll click OK. Once you've done this, you can see right here that we stack the data, and you have the standard deviation of 2,323. You also get the mean, the median, and the IQR. Now, the IQR is also something we will not ask you to find by hand on the test. So you won't have to find the IQR, but you should know how to look at data to find the IQR. What is the IQR of this data on the screen? And if you get something wrong via Jump on a homework assignment, please let me know. Sometimes Jump does a different calculation. That really drives me crazy. But just be like, hey, Brian, give me my points back, and I'll give you those points back. So what is the IQR of this data? And then we'll just briefly mention what the IQR is here. What is the IQR of this data right here? It is 650. Great job, Michelle, right there. The IQR is a distance. The IQR is the distance between Q1 and Q3. So when you think about the IQR right here, divide your data into 4 quarters. So we have here 4 quarters of our data, and then you put your 5 lines. We have here how much money we have adding up across the bottom from 0 cents, 25 cents, 50, 75, 100. And the IQR is just this distance right here. This is the IQR. So all you do, and it doesn't matter which way you do it, Rock knows. It doesn't matter. If the IQR was that the youngest, the 25th percentile of age in this class is, let's say, 18, and the 75th percentile is 23, calculate the IQR for me right now. So we asked people their age in this class and the 25th percentile, which is the lower values. The lower 25% had an age of 18. So like if you put everyone in a line, the 25th person in that line, if there was 100 people, would be 18. Isabel got it right there. That's the issue is how much. Yeah, tell me, Michelle, I can correct that. There's like 1 or 2 questions. It drives me crazy. And I give a rant about that because there's 9 different ways that statisticians have to calculate quantiles. I'm so sorry. Please let me know. It's been an issue. 1 through 100. If you go here to type, there's 9 different ways to calculate quantiles. Michelle, let me know, and we'll fix that. Just be like, hey, Brian, give me my points back. But this is why software like R will show you the 9 different ways. And I'm probably I might even try to go in and delete those questions later. But there's 9 different ways, according to statisticians to calculate the quantiles. Because they don't know. Statisticians are like different mathematical ways. So you can actually change the way they're being calculated, and they're still just kind of quantiles. When it comes to the test, what formula should you have memorized? And let's put that here in our notes. What formula should you have memorized when it comes to the test in computing the IQR? This is the last little note on this, and we're going to go new topic. What formula should you have memorized when computing IQR for the test? What formula should you have memorized? What formula should you have memorized? Who knows? Q3 minus Q1. Great job, Michelle, right there, and Sierra and Isabel. So Q3 minus Q1. And these stand for the quartiles in the data, the first quarter, the third quarter, and you can kind of see it right here. What is the first quarter of this data, which is the middle of the bottom half? What is the first quarter for this data right here? The first quarter for this data would be 550 because it's kind of the middle of the bottom. This is from the 50th percentile to the 0 percentile of the data, and that's the 25th percentile. And this will actually get it correct. Jump, I think, gets this one wrong. Found one that Jump doesn't like. Please tell me if you think you get your points back. I'm very open to responding. You can message me on Discord. Be like, hey, Brian, check my question. We give you points back. The upper quartile here would be 1150. And then we can see the distance between these two is 600. So the IQR here is just going to be these 2 numbers subtracted. Don't worry if you subtract them the wrong way. Remember, it's just a distance. So if you were to get something like this, negative 600, it's just 600. It's an absolute value idea of how far are those 2 numbers away from each other. Think of it, the interquartile range. What is the distance between the quartiles, the inter ones, the 2 middle values, and the 2 middle quarters? So any last questions about finding these values, which values you're responsible for? And I do want to show once again, I've highlighted the mean and the standard deviation because those go together, and the median and the IQR because those go together. The median and the IQR are based on positions in the data, the 50th percentile, the distance between the 25th and the 75th percentile, where the mean and the standard deviation are heavily impacted by what? The mean and the standard deviation go together because they're measures of center and spread respectively that are heavily influenced by what? So those go together. And we would give you those values on the test, the Q3, Q1. They're influenced by outliers, exactly. The median and the IQR are not influenced by outliers, like the max and the min would not influence those because they're not part of the positions of the 50th percentile or the 25th and the 75th. Any last questions on this? Let me know. We're going to go to the next question here in a moment. But this has kind of been a review of finding these values, how you'll be responsible for them on the test. And also, if you have any problems in Jump, let me know. or with the answers on MyPearson. We will fix those up right away. I think we might be good. Let's do a break in the video and do another section right here. You got it. Thank you so much, everyone. That was a really good review right there. I saw some people joining in from the upper level classes too. Absolutely awesome. We're going to do a MyPearson stem and leaf right here. A stem and leaf displays what data. I want you to tell me how many variables, and I want you to tell me what type of variable. Stem and leaves display what data. It's a good note to have if you don't have it. Stem and leaves display what data. I'm loading it up right now. Think about that. Is it quantitative or categorical? Do they display 1 variable, 2 variable, 3 variable, 4 variable? Stem and leaves are a what display of what data? Univariate quantitative, exactly. Univariate quantitative. Like, what else could you use instead of a stem and leaf? I'm trying to pull up the stem and leaf. What else could you use instead of a stem and leaf? Like, if I was like, I don't want to use a stem and leaf. It said stem and leaf finding the median. I'm trying to find that. If you didn't want to use a stem and leaf, a histogram, great job, Gabrielle. You could use a histogram. Anything else? How about something with a D? What? What else could you use? You could use a histogram. Anything else? Box plots. Sierra, great job right there. Box plots, exactly. And dot plot. We use a dot plot, a histogram, a box plot. What could you not use? Hopefully people don't read. I saw one with a... I'm looking for the snap. Oh, found it. Found the question. Let's go check it out. I was filling some space with some stuff. So we could make from this a box plot. It could be... Kind of looks like a histogram. You look at it. Now be careful. Is this very left skewed or very right skewed? Good to see you here, Liz. Is this very left skew or is this very right skew? What's your thoughts on this histogram right here? Is that very, very left skew or is that very, very right skew? Ooh, careful. It's a 50-50. Great job, Michelle. It is very right skew. And great job, Matt, also. It is right skew. Now, don't worry. Someone might answer in a second here. It's left skew. It's a common error to think it's left skew because a lot of people will do this and say, aha, left skew. Brown told me Monster Man. We'll draw him a second here. But what's wrong with this right here when people do this and they say, aha, it's left skew? Solved it. Easy question. Free points. What's wrong with this right here? What's wrong with this? This is the common error where people say, you told me. I say, I'm sorry. This is a common error. So here's what it looked like originally. And then this is what people do. The issue is the values are descending. Michelle, great job. 50 points. Michelle, keep those answers coming in. That's exactly what I wanted to hear. So what we really should be seeing is we should see the values on the bottom in the proper order. So you actually have to do a mirror image of it. Where's my mirror image button? Really? Can I not mirror image this? Wait, rotate. There it is. There we go. Okay, so now we've got it. It was mirror image. Now the numbers go from lower to upper. So we always do our little Monster Man here. And we say right to the high, left to the low, whatever way the Monster Man's tail goes. So there's Monster Man. Got his tooth right there. And there's the Monster Man tail. And it's right to the high. That's right to the high. And left to the low. Make sure it goes in the proper order, though, because if you have it mirror imaged, you can have a problem. So we have the histogram right there. What measures of center and spread are appropriate? Center. So don't answer the question yet. What are the two measures of center? So don't worry about what they're saying. Don't worry about all that up there. What are the two measures of center? Just remember back from our review right here. What are the two... What are the two measures of center? What are the two measures of center? Mean and median. And because this is skewed, you will use the what? So the two measures of center are mean and median. Because this is skewed, you will use the what? It is very right skewed. Because it is skewed, you will use the what? You will use the median. Now, if you look at the color coding on here, the color coding, Gabrielle, great work, Gabrielle Mod right here. Because of the color coding, I've already kind of answered the next question. The IQR, which is also based on positions, will go with it too. So the skew has decided for us that we will use the median and IQR. If it's more normally distributed or it could be less skewed, we'd use the mean and standard deviation. We do try to give you obvious questions. Like this is an obvious skewed data set, so obviously use the median and IQR. Skewed meaning it's pulled in one direction, like there is extreme high values, and that's right skew. So the median and standard, my brain's booting up. The median and IQR are the best statistics to report. There we go, right there. Without doing any calculation, what must be larger? So finish this sentence. The blank follows the skew. So let's talk about measures of center. The blank will follow the skew. The blank will follow the skew. If we were to look at a data set right here, and we did 1, 2, let's say 297. The mean will follow the skew. The mean will follow the skew. What is the median of this data set? Who can find the median of this data set? What is the median? What is the look at this data right here and tell me the median. And good, I'm gonna throw some 50 points. Thank you for all those answers. Don't worry if you get it wrong. If you get it wrong, you're here to practice. The median is 2. Now I purposely chose 297 because the mean of this data set is what? The mean of this data set is what? I'm blocking it. The mean of this data set is what? Maybe over here somewhere. Good morning, Jake. Good to see you here. The mean of this data set is what? 100. Add all the numbers up, divide by 3. So I purposely chose 297 to make it work. So you notice the mean will go towards the whats. The mean will go towards the whats. So finish that sentence now. The mean will go towards the whats. The mean will be pulled towards the whats. The mean will be pulled towards, there's 2 answers that are acceptable. Towards the outliers, towards the skew. Exactly. Outliers is what I was looking for. And skew also works. That was like the second answer that popped into my mind. So when you think about this right here, and if we look at our data, and we think about how our data looks, the mean is going to be pulled in this direction where the mean, I wanted this line. The mean, it's not going to be that high. It's going to be over here. That's where the mean is going to be at. And the median would be down here somewhere. Does that make sense conceptually right there? That the mean is going to be pulled towards the outliers and the median is not impacted by those. Like this extreme value could be all the way over here and that would just increase. It could be on top of my head and that would just change the what. If that value was more extreme, it would just change the what. If that value right there, that 33 was more extreme, it would just change the what. It would just increase the this. If that 33 was more extreme, it would just increase the what. It would pull with it the what, the mean, exactly. So the mean would go with it. The mean follows outliers. The mean would follow that over here. It would, because you're averaging a higher value. You're taking a larger value and averaging it with the other ones. But the middle value is still the middle value. So the middle value doesn't care. It's just a position. It says here's where the middle is, and that high value can do its thing. It's gonna be its thing. Without doing any calculations, which must be larger, the mean will be larger than the median because the data is right skew. If you want a quick note on this also, right skew data, mean larger than median, left skewed data, mean less than median. So the mean is less on left skew, the mean is larger than the median on right skew because it follows it. So now we need to find the median and find the IQR. Thinking of the best way to do this. There are 51 regions. So let's see here. With 51 regions, let's see. Probably the best thing to do is going to be copy to Excel. So I'm copying this data to Excel. And it's opening up. Awesome. I'll show it here in 2 seconds. Okay. Where am I? Enable edit. Okay, we're good to go. Okay. So there's 51 regions. I know this one's a longer one. 51 regions. What is the middle region number? So remember our little trick. I'll pull it up on the screen here. If there's 51 regions, how can I find the median region? And this one is a bigger one than we would do on the test. Not a big fan of it. We'll do it by hand right here. What would be the median region? What would be the median region? 26. Does that make sense? So then take 51 right here. And 51 plus 1 divided by 2. So to be 26. Good job. Michelle, good work right there. So it'd be 26 right there. And then make sure to, before dividing by 2, oh, you did the plus 1/2 right there. Make sure to 51 plus 1, then divide by 2 right there. So good work right there, Liz, and everyone, good practice. It'll be 26 because this will add up to 52, and that'll be right there. So it's n plus 1, n being how many observations? 51 observations. And then we add 1, we divide by 2. So the 26th number is the median, which is right here, and that is 6. So now we go back and we put in 26 right here for the median, and now we need the IQR. So the IQR for this one is a lot less fun. I think Jump does this one perfectly fine, but if we have 26 upper numbers and 26 lower numbers, then we can go and find the middle of the upper, because if there's 26 numbers above and below, then the what number right here would be the 75th percentile, because these are the higher numbers, the top of it. The percentiles, the higher numbers are the upper percentile. So 26 numbers, think about what is half of 26. What is half of 26? What is half of 26? So if you were to divide that into halves, it'd be, I think you might be for the later one. Yes, so you have an answer for the later one. Here's this one. And then I think right there we go. And we should have, I want to show you something here. And this is what you should see. What have I visually created for you right here? Hey, Leela, good to see you here. Who can tell? I've got 5 lines on here. What have we visually created on the screen now? This is good practice. Good seeing it visually here. What have we visually created on the screen? You can see how they're like evenly distributed. We've created the what? I think there's 5 lines. So we've got like the lowest value, the highest value, the Q1, the 5 number summary, the 5 number summary, which is the min, the Q1, the median, the Q3, and the max all the way up there. That is the 5 number summary. And you can see how they're evenly spaced throughout. So you can see the even spacing of the values right here for the 5 number summary, showing us what's going on right here. So we have the 5 number summary evenly spaced throughout, the min, the Q1, the median, the Q3, and the max, all nice and evenly spaced right here. So the values we were looking for was the 39th value, because it's 13 up from here, 13 up from 26, and also the 13th value. And if you can see here visually on the screen, what is the IQR? Now be careful. It's kind of the same. What is the IQR? It is 6. It is 6. And how are you finding 6? How are you finding 6? Good work right there. Good practice. Why is it 6? Why is it 6? 9 minus 3, exactly. It's the distance those numbers are away. Does that make sense? And then, yep. So, and then Isabel, you might have taken the rankings of the numbers or the order. So we want to use the actual values. So Isabel, great work right there and good practice. We're going to use the values because in the 13th position is 9, in the 39th position is 3. So the distance between 9 and 3 is 6. Yeah, no worries. 50 points. Good practice. We have a saying, we get things wrong in class to get it right on the test. Imagine seeing this for the first time on the test. You're like, you see it in class a bunch and we get it right. So that's got that. I think we've done it. Boop. Oh, wait, look what I did. I did it wrong. I did that. Oh my gosh, no one caught that? I put 26 for the 26th position. I was going to get some. Isabel, I did it, no joke, like not on purpose. I took the position of 26. I did the same thing. What's really great, and sometimes your brain blinks, is when we're doing these things in R, we just get it like that. Like I can get the 5 number summary in seconds. I could change this to quantile and just get the 5 number summary like that. I can even change this to IQR and get the IQR like that. So sometimes you make an error. So don't worry, that error you made, I made also, it looks like, and hopefully no one else got caught by that. But it makes sense that the median is 6 and the IQR, which is the distance between 3 and 9, the 25th and 75th percentile respectively, is that. Okay, the distribution of the regions are It's very unimodal. Unimodal means what? Unimodal. Modal means an area of concentration of data. So what does unimodal mean? What does unimodal mean? What does unimodal mean? Like break it down into unimodal. Modal being a concentration of data area. There's one mode, exactly. And it's kind of like one mode. And modal means not just like a mode value, like mode is most often. So you have to watch out, because I've had people say, well, isn't there like some numbers, like 6 appears as many times as 3, so it's bimodal. When we think of, and peak right there, Gabriel, perfect answer right there. I'd say 1 peak to a mountain distribution. I do want to mention briefly right here, when you think about how many modal areas there are, we have this right here, which is clear bimodality. This right here is kind of bimodal. And if you get something like this right here, that might be more like outliers. So at what point is it bimodal? I always think about, you go out with your friends to climb mountains, and you would definitely say if you went to climb mountains that there was 2 mountains here. Yeah, maybe there's 2 mountains here, but over here, that's just a little hill. So it's a little subjective when you say things are bimodal or unimodal, but this is clearly bimodal. Yeah, that's bimodal. This is probably not bimodal. Does that make sense? At what point we would say things are bimodal versus unimodal? The bottom one is more of an instance of like some outliers on the high side, not really a second modal area. So mode meaning most often, modal meaning an area of concentration of data. So kind of think of the mountain example here, and that this is clearly one mountain with an outlier over there. That's just a little rock you go over to get to the mountain. Clearly unimodal data. There is one outlier. Yeah, it's just a little tail to the distribution. Should be got it all correct. Got it all correct. Really good question. Really good practice. Really good concepts right there. Any last questions about this before we move on to the next part? I think we might have one more thing for 201, then we're going to do some 474. Stacking and splitting histograms from Met right here coming up next. Any last questions about this? I'm going to go here to the main screen, but ask those questions right away. I want to give a huge shout out. Thank you so much. We got Liz and Matt and Jessica and Michelle. I think, do we have 2 Michelles here? I think it was Michelle's Unite earlier. We do have multiple Michelles here. So shout outs to all of you right there. We're going to throw a big 100 points. Thank you for being here. And was there, Matt, were you wondering about a homework question, or do you just want me to kind of cover stacking and splitting histograms? Like, do you want me to, I can kind of talk test-wise on it. What would you like? This is going out to Met right here before we go to 474, but kind of give me some direction on this. You said stacking and splitting histograms. And then we're jumping to 474 next. Some really good office hours this morning. Just cover those topics. Yes, test-wise, you bet. You got it. Okay, let's talk about some stacking and splitting of histograms. Okay, stacking, splitting histograms coming up in a second. Here we go, let's do it. So histograms are what kind of data? A histogram requires that we have what kind of data? Histograms. What are they? What are they good for? Absolutely nothing? No, they're totally good for something. And Liz got right there, quantitative, and Matt got it too. Quantitative data. Generally, we think of histograms as, so they are univariate quantitative data. Now, stacked histograms are where you take 2 histograms and you stack them. Lesson over. Class over. We're done. I'm just kidding. Stacked histograms. So to stack a histogram, you need to break it apart into categories. So this is actually a bivariate display because we have 2 histograms split by a categorical variable. So the kind of key difference here with stacked histograms is that they are basically just 2 histograms with a categorical variable acknowledged. Now you say, well, wait, histograms are quantitative, right? Histograms are quantitative, but we're just making 2 of them. So think of it, we have 2 groups right here, and we want to look at the differences between the groups. So imagine you own, what kind of store? I want you to tell me what store you own. We're going to make up our own data set right here. I've got ideas. What kind of store do you own? What are you selling? What kind of store? We'll put store. We'll put sales. So we're going to do daily sales right here. Candy store. Oh my gosh. There was a candy store in Haynes Mall where I grew up. And oh my God, you go and buy those. You ever buy that big jawbreaker right there? The one you just go, like, you know what I'm talking about. Is that jawbreaker that's like this big. Are you going to try to eat it? No, you're going to break your teeth. Not that I've ever did that. But man, those things right there, that's what I think of. Just like craziness. You got the Jelly Bellies, all the Jelly Bellies. Oh man, don't get me started on candy. Okay, so we got two candy stores. We got a candy store in Knoxville, and we got a candy store in Nashville. So we are going to record our sales for, let's say, 10 different days between the Knoxville and Nashville stores. Now, we really care about how we're doing right here. Does this make sense to everybody? We got our candy stores in Knoxville. We got our candy stores in Nashville. And this is in thousands of dollars, how much we're making. So this is thousands of dollars. Well, that's not going to make that much. In thousands of dollars, our sales. I'll start mixing it up a little bit here because it's very repetitive. But we have our candy store sales in Knoxville, our candy store sales in Nashville. Does this all make sense? Who's following along? Candy store sales, Knoxville, candy store sales, Nashville. Who follows? And this is how much thousands of dollars of candy we sell. So that was $3,920 in candy right there. Does this all make logical sense? Who follows? No one follows. Everyone's very confused in the chat. Anyone see this? Tell me, how much did we just sell in candy in Knoxville on this day? How much did we just sell in candy in Knoxville on that day? How much did we just sell for Knoxville candy that day right there that I've highlighted? How much candy was sold in Knoxville that day? Any idea? How much candy was sold in Knoxville that day? 5,230 exactly, Matt. Great work right there. 20 points. You got it. So let's take a look at the Knoxville versus Nashville sales. Okay. So here we go. Analyze distribution, daily candy sales. It's very right skew. Does this help us understand the differences between Knoxville and Nashville? Does this help us right here understand and compare Knoxville to Nashville, yes or no? This is a histogram of daily candy sales, where the highest daily candy sales were $7,320. The lowest daily candy sales were $2,100. Does this help us understand the differences right there? No. We would need what? We would need what to understand these differences? What would we need to understand these? We made a histogram. So we just made a histogram. What should we make to compare daily candy sales, which is quantitative? That's a quantitative value between two groups. What should we make instead of a histogram to compare daily candy sales between two groups? What could we make? One of the options would be this. Because daily candy sales is quantitative. How much candy did we sell monetarily? We can make what to compare two groups and to see which of them is higher or lower. Two histograms, which is called stacked histograms. Great job right there, Michelle. Two histograms, which is stacked histograms. One from Knox and one from Nashville to compare the sales exactly. So what we could do, does it have the option? There might be an option under, I don't know. We have to go back, and go to analyze distribution and do by store. So now we're doing, if you notice here, we have the Y variable of interest, a quantitative Y variable. And now we have down here, we're splitting it apart by store. So we're not doing an analysis of store. It's just splitting it apart into two histograms. So when I click OK, we're still going to be looking at how much candy was sold, but we're going to split it apart into store. Now I'm going to go up here to the very top and click stack. So I'm just stacking this. That puts it into vertical layout. I'm going to make this look all pretty right here. And now, which place is doing better? Now, be careful. This is a trick question. I'm trying to make it so you can see both pretty clearly. Which spot is doing better, Knoxville or Nashville? I mean, Nashville's kind of got some high values over here that are kind of as high as Knoxville. There's a trick question. And I mean, Knoxville might have one of the lowest values right there. Which one of these is doing better? Now, watch out. It's a trick question. because Nashville's got those high values right here. I mean, that's higher than Knoxville there. Catch the trick. There's a problem. So, I mean, Nashville is kind of higher. It's as high as Knox right there, right? Right. Well, Knoxville is doing better. Yep, you can tell by the summary statistics. Knoxville is doing better by the mean. What's the issue when you stack histograms? They need to have what? And I'll show you right here. We need to go to right here and go to where's the button? Uniform scaling. There it is. Uniform scaling. We need to go to uniform scaling because they need to have the same axes. So when you click uniform scale right here, same horizontal scale, exactly. That is essential. It could have the same vertical scale too. Same bin width is good too. Like keep everything the same. And whoa, look at that. Now it's clear which of your stores is doing better. It's super clear. Type it one more time when you give these the same scale, because now both of these go from 2 to 8, 2 to 8, where previously they didn't. Previously they had all different scales on them. Now they're on the same uniform scale. So now it's super clear again that which store is doing better candy sales. Super clear. Like, definitely this store. Definitely. So a key concept here with stacked histograms, which is a quantitative variable split into categories. So it is a bivariate display because it's doing two variables. Once again, we are looking at a quantitative variable. It's clear that Knoxville is doing better. Definitely Knoxville now. You can also see it, once again, as we said, by the summary statistics that the mean is higher for Knoxville. Also, the median is higher than the, and we should probably use median. See, the mean is skewed right there. That's the mean in a box plot. Knoxville's more symmetric. Nashville's more skewed. One other thing we could do, take a quick note on this, is we could do what's called side-by-side box plots. So you could do side-by-side box plots over here, and here are side-by-side box plots, making it super clear that Knoxville is better. You could also make histograms, right? That's not a histogram. Don't do this. That's not right. You can make histograms over here. That's kind of sideways stacked ones. Side-by-side box plots. Here we'll start over, and we'll do the stacked histograms this way. Graph Builder is really neat because you could make your histograms here and display it to somebody like this. And you notice now they have just one axis. So this is giving them a shared axis right here. And we can see that Knoxville has much higher sales. And this is the same stacked histograms of sorts. And a pretty decent graphical display if you wanted to include it in a report to say Knoxville is doing a good bit better. Do we not have, can we not add a count axis? I don't know how to add that to this. I know how to add it over here. If you go to histogram options, and count axis right there. There you go. And that'll show you the counts of the observations in each bin. Any last questions on this, Met? Do remember that we can make stacked histograms, or we could make side-by-side box plots is another option right there. Side-by-side box plots are going to be box plots which are quantitative and can also display this data. So stacked histograms and side-by-side box plots are two good ways to compare quantitative distributions. Stacked histograms and side-by-side box plots are two good ways to compare distributions. How to decide which graphic to use? This comes down to just preference. It just comes down to preference and which you think looks better. Box plots show the 5-number summary. Good note to have right there. Histograms can give you more of an idea of skew. So if you're comparing a lot of distributions, box plots are generally better. I'll show you one quick graphic right here. And this will be a good branch into 474. Box plots in Plotly in R. So what we can show, this is what we do in the upper level classes. We use something called Plotly in R. And a good thing about box plots is imagine if these were all histograms. This is a little bit much data. But imagine if these were all histograms right here, it'd be too much. It's already kind of too much anyways. But especially with the graphics we can make inside of R, you can actually deselect the buttons and just see certain box plots right there, which you can tell that the very good has fewer outliers, where the ideal has more outliers. And you can even hover over this and see the max, the min, the 5-number summary, which is super cool. And this is what we do in some of the upper level classes. These are interactive graphics you can put on the web, and you can even kind of zoom in on them right here. But one of the good advantages of a box plot is box plots are kind of more condensed. They also show the 5-number summary, but they don't show as much as the shape of the distribution because you just get like this box, which is the IQR, and then the min to the max. So there's advantages and disadvantages to each. That's why there's not really the perfect graphic. Does that make sense, Matt? There's no perfect graphic for displaying anything. It's just like, I like this. And then you choose what you like. And then you make it look cool. And that's why I love that, especially with what we can do with R. I love what we can do with Plotly. Well, that's really good. Yeah. No, and Matt, I think you mentioned using R. If you want to do anything in R, let me know. Especially if you just message me on Discord or email me or whatever you like. And you're like, hey, Brian, I want to do this thing in R. Help you out with it. I'll even give you some of the code because I always want to foster this idea of like, there's so many cool ways of do things. But we don't require students to code in 201. So I can't be like, oh, just create the figure and pipe it through and then overwrite the figure here. Make sure you've loaded up the ggplot2 diamonds data set. Here's your X variable. So yeah, I don't expect people to know all this code right here. Let's head back to some 474. Thank you, 201. Excellent work this morning. Swing by with questions anytime. Okay, 474. It's time for a little bit of R. We got our R wheels spinning in our head right here. Okay. Shreya, we might just have just enough time. 4H and 4. Here we go. Got to get over to it. I got to see Sonic 2. Got to be fast. Here we go. Let's do it. Okay, so we got 4H and 4I in Lab 1. And if we're in an RMD file, we can actually click down here. Where's 4H and 4I? Here's 4. Oh my gosh, look at all this. Look at all this. I bet it's some logical stuff. I think I know what we're doing right here. So logicals inside of R are what's or what's is. So if you hear me say logical, you should think what's or what's. I think we're going to be dealing with logicals, or is it subsetting? 4H and 4I, here we go. It is logical. So, yeah, we'll definitely, Shreya, you bet. Thank you so much, Shreya. If you hear me say logical, then I'm going to put in a chunk right here. Boop, chunk. What are logicals? Ones and zeros works great. Great job, KP, right there. Ones and zeros are actually trues and falses. So if I do true plus true plus true, what does that equal to? True plus true plus true is equal to what? What is true plus true plus true? Anyone know? Because they're ones and zeros. So true is 1. So what's 1 plus 1 plus 1? Great job, KP. That's 3. So trues and falses are ones and zeros inside of R's brain. That's going to come into a big play right here. I lose it. So let me make sure all the data is loaded up. That loads all chunks above. We should be good. I should have everything loaded. This is the load all chunks above, and I added in this chunk by going into add R chunk just to a blank space. This is the name of the chunk right here. This calls the chunk. This is kind of the programming for the chunk, and that ends the chunk. Please let me know if you have questions. That's kind of some basics of chunks and RMDs. Remove that. A chunk is where you write code. So this is basically a Word document here, and then this grayed out portion is a R chunk where you do code inside of an R markdown file. Please, if you have questions, let me know. Just some kind of things to understand right there about how an RMD file works. You have the Word document portion up here, and then you have a code chunk here where you run code. You can also adjust the options by clicking the scroll wheel. This runs current chunk. There's nothing in there. And this runs all chunks above if you have any code that would create the data frames that you probably need, which I needed. What fraction of households spent between 20,000 and 30,000? Calculate this by taking the mean of a logical condition. So we're working with the which data set here again? There's the lab 1. Let me clear out my data frame. Let's see here. Good to see you, Rod, and everyone. Okay, let's run up. Which data frame? We got data right here. Household, there we go, spent. So there it is, the data spent. Thank you so much, Sydney, right there, 20 point. Data spent. Okay, here's the values. How would I get households that spent more than 20,000? How am I going to get households that spent more than 20,000? How am I going to find households that spent more than 20,000? How would I find that? How can I find a household that spent more than 20,000? How can I find that? Exactly, KP. You got it right there. So what I want to do is I want to run this one time, and I want to make sure we see right here maybe some trues. No one spent that? Well, let's find out how many of them, because we're going to find out. What? Well, that's, oh wait. What fraction? Well, that is the fraction. Mean is going to give us the percent, and there are only 6 households that spent, yep, oh, I did, is it 2,000? That's right there, right? That's accurate. What fraction of households spent between, so I haven't done the second portion of it yet. We're just kind of doing it in, as we like to say here, little bits. Oh, no worries. No, don't worry. I was just doing the start of it. So this represents that fraction-wise, 0.0024, because I did the mean and I did the sum. There were 6, and that's why we get right here the fraction. 6 divided by this right here is that value. Does that make logical sense that the mean is showing you the percent that meet the condition? The sum is showing you how many meet the condition. So once again, if you do the mean of a logical, it tells you the percent of truths. If you do the sum of a logical, it tells you how many truths. So there were 6 truths out of the 2,500, which is this fraction right there. Not really, I said percent, but it's a fraction. If you times it by 100, it's a percent. So understand what the code is getting you, that this is how many truths there are. Let's put it back to the mean right here. And what we want to do now is we actually want to find out 2 conditions. We don't just want that it's greater than 20,000. We want and it is less than or equal to, really? Less than or equal to 30,000. And there it is right there, which I think should be how many households? Could you do... Oh, and so you don't want the comma. Good question. Jake, 50 points. Thank you for asking. The comma will separate it into a second condition. We use an and. So you'll connect it with an and because you're basically saying, does it meet this and does it meet this? So you're saying, is it this and is it this? Does that make sense? Can anyone tell me how many households this would be? Kind of look at the math right here because I can find how many households there are by doing this. But can anyone tell me... Just look at the math of this and think this was 6.0024. This is going to be something. Just mathematically think 6 divided by that, and you can find out what the 1 out of 2,500 is. So what would be the sum, which would tell you how many households meet this condition? Which, interestingly enough, I could find out some other values by thinking about this logically right here. How many households would this be? Sum tells you how many households there are. I like doing this because if you... I haven't told you which one the answer is. It's 5. Yep, Sierra. It's going to be 5 right here because 5 divided by 2,500. Do you know what this will be logically? How many have greater than or equal to 30? Oh, wait. With that? Yep. This, I can tell you the answer to this code. The answer to this code is going to be 1. And how'd I know that? I knew that because remember when we did, there were 6 households that had more than 20,000. There are 5 households that have between 20 and 30,000. So this one household has to be the one that had more than 30,000. It wasn't contained in this interval. You don't have to know that kind of stuff logically, but just make sure you kind of understand what you're getting. Make sure you can read what the code's giving you and be like, okay, that makes sense. If there were 6 households that had more than 20,000 and there were 5 that were between 20 and 30,000, that means one of those 6 households was more than 30,000. Just some logic of understanding what we're getting. So I'm kind of just leaving it at this. The question itself states exactly what you need to find. I think Jake, do you have the answer for what you need now? Because the question states what you need. I'm leaving it at this to kind of like Brian found the answer here somewhere. I found the answer somewhere in there. I'm not going to tell you which one is the answer, but we definitely showed the answer. What fraction? Tell me if you had a question on that, but we definitely showed the answer there somewhere by talking through examples of it. What fraction of values in kids are missing? Calculate this by taking the mean of a logical condition. Okay, so how do we find if something is missing? What is the code to find if something is missing? Now, we talked about the as dot. As dot saves things, but there's a logical check with another family of functions, not the as dot. How do we find if something is missing? Is dot. Exactly. Great job right there, Sierra. Is dot NA. So the is family, you can ask, is something something? Is it numeric? Is it this? Not that many is dots. So is dot NA will tell you if something is NA. Is NA NA? It is. So that's what it does. Is 2NA? No, 2 is not NA. So what we can do is we can take a vector and we can go here to the data. If we spell it properly, kids, and then what do we get? We get a vector of trues and falses. So now we can find out, and I'm not doing the same question yet, we can find out how many trues and falses there are by doing the what of this. We can find out how many trues and falses there are, or how many trues are, excuse me. We can find out how many trues there are by doing the what of this vector. Like if I want to say how many trues there are. If I want to know how many trues there are in this vector, what would I do to it? Length is going to tell us 2,500. Good answer right there, Rob. It's going to be 2,500, which is, and I guess that was my first question. 100 points, Rod. That is going to be it right there. There could be a missingness in a logical vector. Logical vectors could have missingness. That's how many elements there are in that vector is the length. And then the sum will tell you how many trues there are. There's 1,699 trues. Now, what you could do is you could go the long way here, and you could say, let's take how many trues there are and divide by the length of the vector. You do have to watch out, though, because if there is an NA in your vector, it can create discrepancies between the way things are calculated. So the more preferred way of finding out the percent of trues is to just take the mean of a logical vector. This does come to the same conclusion, but I have had instances where one of the elements of a logical vector is missing, and that'd be weird if you did an is NA and you found a missingness of, I guess it might, let me see. Not a number is missingness. That's interesting. Not a number is missingness. So not a number is a type of missingness. I didn't know that. It registers as missingness. Maybe, no, you can't have a null object. That will return logical 0, I think. Yeah, logical 0. Logical 0 represents a vector of 0 length that's a logical class. So that is a logical vector return with no elements in it, because null is nothing. I don't know if I could have answered that for you a few years ago, like in depth. A lot of students have asked, like, wait, what is logical 0? And then first time they asked, I said, I don't know. It's a logical vector of length 0. So it's telling you the class of the object returned and that there's no elements in that object, such as if I create here x, this, if we look at x, it is a null object, but I wonder what the class of it is. It's null. It has no class. 4e, let's do 4e right here. Good question right there. What is the largest values in visits? How are we going to find that? Good question right here. Who can help us out? What code do we have in Sydney? Thank you so much, 20 points for asking that right here. Perfect time to ask. How could we find the largest value of visits? We're going to go a little bit over office hours today. We're going to find max. So let's go right here and go to max and data and $ visits. There we go. There's the largest value of visits. Alternatively, you can do it by clicking on here and going to visits and sorting it like this. So you can kind of do it visually speaking too. So especially maybe if you're working with clients, you could sort the data set by clicking the data and then going into it and clicking the column to find the value. Oh, no worries. Do you see how this is in position 1510? You can also find out the position of the max with a function called which.max. And that tells you the position of the max. Now, that's not the value of the max. That which.max function represents the maximum value is in position or row 1510. The max is not 1510. It's just that the position of the max, because it's a which function, which tells you positions. So it goes and finds the max for you and then tells you the position of the max. So which.max or which.min are really cool little functions. They're not in the notes, but there's so many little neat functions that do a little specific task for us. If we're like, well, where is the max? And that's very useful if you're like trying to find something in a data set and you're like, okay, let's find this row, because you could use this function right here to report. If you go to your data, you could report the row with the max, and there's the row reported with the max. I did which.max. So now we're in a data frame. We're doing the rows, columns. If I want to find the number at position 100, how do I do that? You're in the data frame, right? Data square bracket 100, and there you go right there. That is the 100th row. Is that what you're asking, KP? Correct me if I'm doing something a little bit different right there. But is that what you're asking right there? You need to go square bracket. If it's a data frame, it has rows and columns. Leaving the column space blank will take all columns. This is asking for row 100. If you have a vector, like for particular spent, data $ spent, and then square bracket 100. So now we're in a vector. Vectors have one dimension to it, where data frames are two-dimensional. We have a row space and a column space, but a vector is just a line of data. So I'm saying, give me the 100th element of this vector. There's no two dimensions to it. There's no rows and columns. This is just a line of data that wraps around the screen. Great job, KP, and great. Keep these questions coming. These are great questions. We're going to do the next question people asked about 7.2b. So we're going to jump to 7.2b, but keep trying to ask those questions. I'll try to squeeze those questions in here. 7.2b. We're going to go right here and go down to 7. Where's 7? 7. Oh, we went right to it. Okay. Ooh, what we got? Love some 7.2b. Let's find out. If you run summary on your fixed product column, you'll find watches B, C, and D are extremely rare. Combine the watches A, B, C, and D levels into a level called watches. Use the safe procedure. Sometimes we don't do everything perfectly safe. Which in the percent, run the table of the column. Okay. So we are dealing with the... Is this the data set we load in? I think we load in this data set. Yep, it's the retail data set. There we go. Okay, so we're loading in the retail data set. Here's our retail data set. And we have watches. Let's go down here. On your fixed product column. Retail. Oh, we have to fix the product column? Okay, wait. Printed the product column as well as the summary. There are 5 obvious to me outlier data interiors arising from the spelling, fashion, Then I fix these levels using the safe procedure referring. I don't know if we have to do this one yet. I'm actually when I saw it, I put the name of the release frequently appearing months. That's fine. Print to the screen the levels of the product column as well as look at the summary. I think we should be good. Watches B, C, and D are earlier. Yeah. Okay, good. I think we're fine. Okay. Oh, right now product is into what? Right now product is into what? What's our first problem with product right now? What is the first problem with product? This is key. What's the first problem with product? It's not a factor. Okay, so let's go here. And Timothy, great job right there. Good catch. So let's go as dot factor. Put it inside of there. That makes it a factor. Then we're going to overwrite. And there we go. So I overwrote it as a factor, and it's now a factor. So now we get some interesting stuff right here. Now, remember, this is where we ended class yesterday. Watches doesn't exist. Watches doesn't exist. What are the extra jump files on campus? Oh, they're for practice, Michelle. Good. Thank you. 50 points right there. Thank you for asking. Mubot loves some randomness too. They're for practice to do because they're like designed around that chapter. So you can do any sort of practice with them. Good stuff right there. So this is where we ended class yesterday for 474 with appending levels. I'm going to go to the levels vector of this variable. There's the levels vector. And I'm going to store into the levels vector a version of the levels vector with appended onto it watches. Now, what you'll notice is if I look at the levels now, or if I make a table of the levels, there will be watches, but nothing will be in it. So you see how watches has nothing in it? And those are numbers. That's interesting. What is going on right here? Let me go look at the product. Something weird happened. I broke it. I broke it because I appended onto it. Yep. There's where the break happened. So let me run all code above. Let me run current code. And the break happened because I stored the vector, I concatenated the vector, not the levels vector. There we go. Always, bye, Michelle. Always look at what you created. I did not take the levels vector and append on it. I took the vector itself. You might be able to, but remember, if it's a factor, so you could recode it before turning it into a factor, then you're just changing the names of words. But if it's a factor, you have to append to the level vector. And it says we should see, there's watch A, watch B. You see, we got watcha, watches A, watches B. So what we can do now is we can go here and we can go to the following. We can go to retail, and when I say percent in percent, the vector, we could do an interest vector for this. Does this make sense what I am doing? I have to go a little quickly because we're running out of time. And then, okay, I think it's the same spelling, just B, and then there we go. B. Please let me know if you have a question about what I am doing. I'm going to see. Does this make sense right here, Tim and Benjamin, everybody? I am seeing logically if the retail product is contained in this vector here. Now, what we should see, and let's call this a logical right here, is if we go to sum, or let's call it an object, we should see the 1,836, and there it is right there. So now what I want to do is I want to get the positions of those. Does that make sense? These are all the positions of those. Does this make sense, Tim and everyone? I have all the positions of those things that meet the conditions. I have all the positions of the things that meet those conditions. So now what I want to do, I could call this positions right here. Like to that. Makes sense? Good deal. This is a tougher one. So good. We got like a few more minutes. And now I want to go to retailer, $, and product. I want to go to those positions, and I want to overwrite them with watches. Remember, I created a spot for watches up here. And now when we go right here, we can go to table, and we can take a look. We should see that there is that many watches. And notice I recoded it. Now what we want to do, I think we need to go to drop levels. I don't use this one so often. There's the drop levels, and I want to overwrite this with this. And there we go. That dropped unused levels. So the drop levels function, not required, but it's a good way to clean up your data. It drops unused levels. So because we're no longer using that watches A, watches B, watches C, watches A, the drop levels, storing it over the vector is going to drop unused levels in that vector. Those zeros that we saw earlier all the way back up there. These zeros that we see here are removed with drop levels. So now we've done it. And what is the average value of the number of orders for the rows that have watches products? It's close to 308. So we need the average values of numbers of orders for these rows. Oh my gosh, this is the biggest question ever. Okay, so now we want to go to retail product equal watches. There's those, and let's go to position 2, and let's go to which. There it is right there. And we want the retailer, is it num order of these. And there's that. And then it says average, should be good on this. There we go. What is the format for the final log? Oh no, you don't turn it in. You just do the questions. You just do the questions. So no turning it in. There's no turning in of this. It's just the questions itself. This was a monster. If you look at this compared to the other ones we did, this was a monster of a question. This was some heavy data analytics right here. So there was a lot of recoding of data, a lot of checking of data. This is a tougher one. This is a real, like, where you have to sit down and I can see. I think the first semester I taught this class, I definitely struggled with a question like this. It's a tougher question, and I've got the full walkthrough right here of everything I was doing. And then at the end right here where I stored the positions and all this. Oh, no, nothing to turn in. Nothing to turn in. You just take the quiz. Does that make sense? The quiz has unlimited attempts, I think I put on. And so you just do the quiz, Tim. Does that make sense? It's just a quiz. Each lab will have a quiz associated with it. And yeah, it's just a quiz. So you don't have to turn anything in. No knitting RMD, no worrying about that. We're going to be assigning the next assignment here coming up in about 2 hours. The next assignment will be coming out. So get ready for the next assignment, which will be a 2 to 5 page report. Do we have time to do another one real quick? We have how does R assign bins and subsetting data. Let's talk real briefly. So when R assigns bins, I think we got to look at the histogram thing for that. How does it assign bins? Will the answer document include the code for that? Yes. Yep. And that's a good thing right there, Sierra. It's meant to be practice. So Sierra, 100 points right there. Why not? That is a really good question. The answer document will have it. The breaks equal sturges? I don't even know. This is how R assigns bins. Wait, here it is. Breaks, one of the single number. That is how R assigns bins. It's via this breaks function right here, and that is how R assigns bins with the default histogram function, which I use some ggplot functions. The other question was how to subset data. So that's going to be a key part of the next assignment. So we'll probably get more into that. When it comes to subsetting, I have some more favored ways of subsetting. We have what are you subsetting? And then we have conditions to subset right here. So we talked about this yesterday, and we're probably going to head off here because we'll be starting the next stream coming up here in a second. But keep those questions coming in. We're doing more office hours tomorrow, and we're right about to jump into class and get ready for the next assignment. Until then, let me do the fast outro thing right here. Wait, where's my outros? Here we go. Bye for now, everyone. Bye.